Hi, Stuart here. Today we're going to give an overview of cloud tenancy and some ways to achieve it, some things you've got to be on the lookout for, and some other strategies. So let's start with a problem statement. Let's say we have a multi-user, multi-organization application in the cloud, and we have an obligation to keep one user's or one organization's data completely separate from the other. So we're just going to call that a tenant, right? So at any level of granularity, an individual, a group of individuals, an organizational unit within a bigger corporation, a project team, you might have scenarios where you have different subdivisions or different parts of a company. Any of those scenarios where a group of individuals needs access to something, and that group can be as small as one, and everybody else shouldn't have access. It devolves down to users and profile information, information about the tenant business rules and so on. We'll talk about that, their data, in some cases network traffic, and we need to make a set of decisions about really what's needed. And one of the number one things that I think many project teams fail to consider when they're working on tenancy, and we'll call it some other ones as well, is how much is each tenant worth? In other words, what does it cost versus what revenue will be had or what business benefit will be had? Projects go horribly off the rails if they forget to keep checking that, right? So we have a set of evolving business rules. We have maybe a hyper vigilant compliance organization, whether that's internal or external or a third party or what have you. But the very worst case scenario is that you get to some level of implementation and in the ultra worst case adoption, and it's just a relentless money loser from any perspective. That is to say, the business value it brings doesn't even come close to the cost. And that cost, you have to consider all of the complexity items, right? The total cost of ownership, the TCO. So that's not just the investment in the running cost of all the infrastructure, it's the aggregate cost of the running cost of infrastructure as you add more tenants or more users, but it's also the investment cost, it's also the maintenance cost, it's the human costs, it's what is the cost of change? Tenanted systems that are not very tightly controlled tend to have per tenant customization as drift. And those scenarios are almost always a sign that doom is around the corner. So if you can't find a way to make those things soft configured, there's a fairly good chance that you're inducing a lot of risk into your project. Let's stop and consider some areas that teams really have to consider. And the first is data classification policy. So every business organization that deals with data should have a data classification policy. And if they don't have one of their own, they can use the one provided by CISA. But then they have to go through the effort of looking at each element or collection of elements that might be in your domain-driven design or your database schema or your storage schema or whatever, and make sure those things are in alignment. And it's not enough for the project leaders to know, right? The devs, the DBAs, the QAs, the individual product owners have to understand that viscerally. And the only way to do that is to make sure that your data governance and classification policy is applied to all the data elements in a way that's discoverable. So if I'm a DBA and I'm looking at a set of schema, or I am a developer and I'm looking at a piece of JSON or NoSQL database, or I'm looking at storage or what have you, there should be a mechanical automated system that allows me to go, this data is confidential or this data is proprietary. And so it's really important that those dots are connected and enforced. QAs for example, can't write the correct tests to validate your data classification policy if that categorization is not documented all the way down to the element level, whether those elements are, metadata on a document that's in storage, or columns in a row in a database, or elements in an XML or JSON scheme, or elements of a wire message, or elements that you might see in a queue or in a cache. The other thing to keep in mind is the in for a penny, in for a pound rule. If the granularity at which you can exert control of your data is at, for example, the document level or the row level, or worse, the container level, then you have to treat all of the data in your smallest controllable granularity as being the worst case of the classification policy of the most strict thing in your database, or your storage, or your NoSQL, or what have you, your queue. In for a penny, in for a pound is a rule that gets forgotten when people are implementing particularly the persistence tier of tenancy. The other thing is there's going to be some external and internal governance. And for many of the things that they're imposed by particularly governments like GDPR or HIPAA, you probably ought to get some professional advice. Now, you may have a compliance organization in your greater corporation that's expert enough to guide teams on how and what to do, but you may not. And in any case, hiring an outside validator to do the sort of compliance testing will let a lot of people sleep well at night, including you. If we're going to be building on top of vendors supplied infrastructure, which this is cloud tenancy, so we're going to say yes. And that can be a public cloud, private cloud, right? So VMware, Microsoft, IBM, Amazon, Google, whoever your vendor is, they will have excellent guides for different kinds of compliance scenario. And they are all in the form of, if this scenario applies to you, we recommend that you do da 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 da. But the tricky part is to figure out whether or not that scenario is a non-functional requirement for your system. And this is where really only the business will know. Once you've identified that something is a requirement, then you can work with your vendor and your development teams and so on and say, what do we need to do to get to this goal? How do we test this goal, right? All things need to be smart, right? They need to be specific, measurable, actionable, relevant, and they have to be time-bound. That's the rule of SMART. That combination, whenever you're working in any kind of tenancy process, that can't be a one and done, like, oh, we'll have a big meeting at the start of the project. No, that's got to be something that's part of a continuous development, continuous improvement, and continuous validation cycle. In other words, an OODA loop: observe, orient, decide, and act. The other big one is regionality. And this is where, again, a lot of tenancy things fall down. Regionality, in a sense, is for a particular tenant. Are there rules about in what jurisdiction, typically a country, but there are cases when it's smaller than a country. And there are cases where countries have some sort of agreement. For example, the European Union might allow you to store data of a particular data classification anywhere in the European Union legitimately, but there will be dissenters like Germany or France. And so it's important to understand, based on the data classification policy, based on the non-functional tenancy rules from your compliance organizations, what your regionality scenarios are. And in a lot of cases where you have a wealth of choice, that is to say, for this group of tenants, they could live, here, here, or here, and it's okay. Then you got to look at costs, and you've got to look at latency and user experience. But you should also reach out to legal, because there's a chance that when somebody, said, oh, I agree to sign up for this thing that we're doing, but I have a requirement, and the requirement is, my company's in Brazil, my data must be in Brazil. And when you're implementing a solution, you have to think long and hard about the fact that even the same vendor's data center in different places around the world won't have the same technology selection. Whether that's because they're rolling it out in waves or because some government or governance organization says they shall not have XYZ, and you have to care about that. So those are all regionality concerns. Here's a warning. If you're building a tenanted system and various stakeholders insist that they'll really only ever have to have data centers within a specific jurisdiction, the first thing you should do is raise your hand and go, what about your future expansion? What if we want to support Central and South America or Europe or Asia Pacific or whatever? And if they say, no, we're never going to offer goods and services there, then you should probably find a piece of parchment, have them sign the agreement in blood and, cross our heart and, hope to explode. But if you really are clever implementers, you will have a plan. Even if you're not going to implement the plan, you'll have a plan where on the day they go, hey, that single jurisdiction thing, just kidding. Can you roll out 4 new jurisdictions by tomorrow afternoon? At least you have a plan. And you haven't coded yourself into a corner where it would be open heart surgery to deploy your application in different jurisdictions and different data centers. Some tenancy basics. Again, all of these are from bitter personal experience where, we didn't think of this and we regretted it later. Do use a known security and identity and authentication system, right? Use something that's well-worn, that is respected in the industry. Use a commercial product that you trust. Azure Active Directory, Auth0, one of the big names that have so many customers that are so well used that your users will not have any trouble federating to it. And secondly, that they're big and well used enough that it's incredibly unlikely that they'll have any significant security flaws. And if they do in fact find one, they will fix it very quickly because there are a huge number of people and organizations that depend on it. Number 2, don't bury authorization in code. Man, have I seen a lot of code that's got authorization logic in it. Authorization should be centralized and follow a pattern called interception, which means that something from the outside, the UI or an integration point or whatever, is making a call to your API, which hopefully is standing in front of your data tier. And the call is intercepted, and based on the state, who the user is, what data they're going after, what tenant the data is in, what their row and column restrictions are, etc., that we get a yes or no answer. And if the answer is no, your API, your database never sees the call, right? We want to externalize that for a bunch of reasons. We want to be able to, as we change our authorization and business rules based on novel new scenarios, new personas, etc., we want to be able to implement them in an external system and then ask a bunch of what-if questions like, well, based on this set of rules we just crafted, what can they now do they couldn't do before? What can't they do they used to be able to do before? And what data can they or can they not see? And being able to test that externally before you flip the switch and say, this is live, and the ability to roll that back if you're wrong is an indispensable part of implementing any tenancy. Do consider a multi-layer defense against one tenant seeing data configuration. And we're going to talk about that some more because it's super important. Do not commingle one tenant's data with another. No matter how cheap it seems to you, you will come to regret it. We'll talk about that more too. Make sure the user tenant mapping is absolutely deterministic. And in fact, if you have a nice authorization externalized system, you can fold user tenant mapping into that authorization system and have one source of truth for a user about what they can and cannot see and can and cannot do, including user and tenant mapping. But you want to make sure it's deterministic, right? That only humans or integration accounts that are allowed to get to this tenant's data can get to this tenant's data, and how and what they can get to is absolutely predictable. And again, the good authorization engines are external. They allow you to do what if. They allow you to do incremental rollouts. They allow you to roll policies back. They have full auditing, right? So that if you have an allegation of a disclosure or elevation of privilege or anything else, you can go to one place and find out if that's true, if that actually could have happened. And of course, we want to put defense in depth around our APIs and integration points so that all of the network traffic, and this is what I meant by traffic shaping on the previous slides, all the network traffic for sure considers the authorization engine. In other words, it and hopefully firewalls and other networking controls are between the cold, cruel world and your tender APIs and data. I know it's tempting. This user, Joe can get to 3 different tenants. That's just great. Well, no, it's not. And if Joe can, then Joe should only be able to do that to one at a time, and then they should log out. In other words, we should destroy their authentication token before they switch tenants. Because otherwise, we risk having multiple tabs in the browser or multiple screens or multiple systems integrations. Because Joe can see tenants A, F, and L, we inadvertently mix and match. And that would be awful. So just don't let it happen. No matter how much the business whines, tell them it's not in their long-term best interest to let Joe get to all 3 of his tenants simultaneously. Right? He's got to pick one to focus on, log out of that one, and if he tries to go to another tenant without logging out of the first tenant, and again, you can make convenience methods so that's invisible to Joe if you want, but the system should never allow Joe access to more than one tenant at a time. Do always make sure that it's blazingly clear to any user or integration what their tenant context is. Like, what tenant am I in? Don't fall prey to the temptation to store secrets for a tenant centrally. We're going to talk about that one too. Do have a master tenancy engine that's capable of connecting to a tenant, and we'll describe how to do that. And don't have tenants span jurisdictions. It's just too messy for compliance, right? So if you have a customer that is a multi-jurisdictional entity, they're Big Corp, and Big Corp has got 17 locations around the world, then they should have 17 different tenants or some function thereof, right? Obviously, if they're in the European Union, you may be allowed to merge all their European Union ones into one tenant or not. It may be that for the reason of business separation that it's actually desirable. And again, if you make tenancy switching and tenancy context obvious, then if I'm the senior vice president of exciting things at Big Co and I want to look from one to the other, I'm going to quietly log into one and then log out of the other one. or rather the converse. I'm going to log out first and log into the other one. But I'll always know where I am. And if there is a special requirement to roll up data across tenants for certain situations, that should happen at the boundary of the tenancy system. E.g., you should set up some data processing pipelines that siphon things out of the tenant engine and produce tenant isolated reporting that does the aggregation. So there is a 7 tenancy layers approach. This is an abstraction that we've come up with over the years that shapes how we think about designing tenancy in a real world scenario. Like, we're never far from this abstraction as we talk about things. First, because it guarantees we're putting the right concerns in the right layer and not commingling them. There should be very, very sharp disambiguations between each of these layers. And secondly, because it brings clarity to all of the stakeholders, including the implementers, the testers, and the product owners. Number 5, by the way, is again an aberration. If you have to do what I call hard customization, that is roll out custom code just for tenant 47, or custom infrastructure or whatever, then you should try to do that at the edge of your tenancy engine. We're not going to go into it. Maybe in a future video we will. But in general, it's an anathema. We don't want to do it. So the abstractions are, who the person is. What is it they can do and what do we know about them? How do those users get mapped to tenants? And then at the tenancy level, right, when now my user is connected to a tenant, what are the tenancy rules, cryptography, configuration, routing, etc.? What is how are we going to separate out per tenant persistence? And at the bottom of the inner part of that well, how do we keep the secrets of one tenant separate from the other? And those layers may be implemented physically on the same infrastructure, but mentally, architecturally, we want to be able to test all of these things separately, and we want to not blur the distinctions between them. So here's a generalized tenant architecture, right? And I'm going to assume that we're going to be multi-jurisdictional. So we're going to start with integrating processes, that's the gears, and users. And we're going to have a web application firewall and some sort of global routing or global traffic direction. And its job, in addition to least cost routing to the appropriate data center, which generally contains the right tenant, right? If I get routed to the Brazil data center, the chances are I'm a Brazilian user or a Brazilian integrator. If I get routed to the data center in France, I'm probably in the European Union or I'm in France, right? But you can override that because you can have the tenancy engine place global routing cookies on the user's desktop if it's a UI, or you can provide, explicit tenancy routing through all your APIs. We'll talk about that in a second. And they can override the global traffic routing and go to the appropriate data center in the region they've demanded. And if they go there and find out that the tenant they're demanding is not there, then so be it. They'll get an error that says, hey, you went to Brazil, and that's great, benvenido. However, HIPAA does not have this tenant in this data center. And it will ideally redirect them and then rewrite their cookie or their metadata or whatever in such a way that the next time global routing will drop them to the right place for that tenant. So combinatorially, since we say we never want tenants to span jurisdictions, that's a technique that works. So we want, we have our UI, and we have potentially an integration API that's out there in the world, right? That's forward facing. And that can include, data processing pipelines in and out. It can include, file transfer protocols, things like that. All of those things are good API scenarios. So by API, I mean just kind of any interactions that are automated as opposed to human interactions, which are obviously through some sort of a UI typically. You want to have your authentication, who am I, engine. Generally, these in tenanted systems are federated. Again, there's lots of good federated authentication systems out in the world. Most cloud providers have a really easy to set up federation where you can say, yes, I'll accept credentials from, this folk and this folk and this folk. And in fact, generally speaking, they can help feed your tenancy engine that makes decisions about what tenants they can see too. And of course, you want global authorization. In other words, now that I know who you are, what can you do? And again, those help feed the tenancy engine and the tenant configuration. So tenant 53 is this tenant. It's got this general information, and I know that it lives in this data center, and I know that it lives in this cluster of back-end infrastructure. And we'll talk about that in a minute. And then typically there's a layer of internal APIs, and the internal APIs are there so that you can evolve your business logic and you can engage all the things in these front two tiers in an integrated way without breaking the contracts, for example, in the API or federated authentication or unified authorization engines, right? They provide a level of abstraction that is useful. We have a big knot through the 5 because, again, we don't want to deploy particularly infrastructure specifically for people. We have a group of 6, so this is any kind of persistent data. And again, let us not forget that the data classification policy applies in for a penny, in for a pound. And then lastly, we have the client secrets engine that is going to, the tenant engine will look at the tenant configuration based on a request from an API or the UI, and it will say, oh, that's actually tenant 53. And tenant 53 is in this data center in this organizational unit. In Azure, resource groups are good for this, or even subscriptions. And we'll say, based on that, I know who to ask to get the connection strings that are stored in 7 for all the various bits and pieces that are part of the persistence tier that are part of 6. You can see that our data center can have as many tenants as you want, and you can have as many data centers as you want. So that's the high level architecture for a generalized tenancy engine. And of course, there are a million variations or riffs on this, but it also shows kind of our layered security zones where a data center is a security boundary, as are the layers or tiers within your application, as is the tenant separation, right? I hear the gears grinding in my own head as I think about this, and this is a lumping and splitting problem, right? And so in a perfect universe, you want ultimate splitting. You want share nothing for each of your tenants. And if you can afford that, right, that is awesome, because that guarantees that since they share nothing, you can never have an elevation of privilege or a commingling, right, data sharing situation. But there's a couple things that'll stand in your way. Probably number one, cost, right? Ultimate splitting is extremely cost inefficient, unless, of course, you can make somebody else pay for it, in which case it's awesome. But it also when it comes down to lumping and you're trying to preserve the client separation, the technologies you choose turn out to be really important. So let's talk about that. So here are some desirable persistence engine characteristics. Number one, and this should absolutely never ever be broken. Do not rely on the code your developers write to enforce the separation between tenants. So if fundamentally, right, we have infrastructure barriers where it's actually not possible to route from the European Union to Brazil, right? We've done ourselves a big favor in that area. And then if we have a level of granularity in whatever our back-end storage is that generates a unique address, and included in that is a unique set of access controls per tenant. So like a connection string, right? If you think about a SQL Server connection string, it has the server, it has some things about user or process identity, right? It has the actual database name. So you could have a single SQL server and it could have, you could say, well, I can probably fit 20 tenants, each with different database names into that, and there's no chance of them overlapping if I set my permissions up correctly, because each of them will have a genuinely unique connection string that works on theirs and only theirs and doesn't work on anybody else. In other words, never ever use super user permissions for at the application tier. And that's true for NoSQL, cache storage, queues, events, whatever, right? The smallest level of granularity your engine will support at the connection string level. And remember, our connection string is going to contain, user or process identity. And so many things like SQL Server or NoSQL allow you to build into the infrastructure itself separation rules based on identity and or an assertion of claims. For example, having the appropriate certificate signature is proof that you're allowed to go to there and do this. And then we have multi-level secrets separation. So if we go back to the diagram for a second, we have tenant configuration, which is the first level of secrets, which is how to find a tenant. But then all of the secrets about a tenant are within the tenant. So having found the tenant, the only secret the tenant configuration really needs to know is, what do I have to tell? What does 4 have to tell? Well, what does 3 have to pull from 4 to connect to 7 to get the appropriate connection string for the thing that's in 6? So multi-layer security in depth, protection of secrets and secret separation. And again, what do we put in there? Connection strings, certificates, other cryptographic things, tenant-specific business rules and configuration, tenant metadata, et cetera, right? So that is a high-level approach to cloud tenancy. And in 20 minutes, I can't possibly tell you everything there is to know about it, but I can tell you that there's the things you should start thinking about. My name is Stuart. Thank you for your kind attention.